Today we're going to be looking at the surface area of 3D objects. Once again, surface area is how much skin is covering an object, essentially. Two other common examples is the surface area is how much gift wrapping paper would be needed to wrap an object, or the surface area is how much paint would be needed to paint all the way around an object. So again, it's the outside areas of an object all put together. And to find the surface area of a three-dimensional object, we actually break it down into its little pieces. We actually break it down to 2D objects. The best and most efficient way of solving for most surface area problems is simply take your figure out the areas of each individual piece or face of the object is what they're called, and then add all those areas of those faces back together. So for example, if I had this box here with a blue top and a red bottom, and I want to find out what the surface area of this box was, what I would do is I would find the area of the top piece first, then find the area of the bottom piece, then find the area of the right piece, then find the area of the left piece, then find the area of the front piece, then find the area of the back piece, and then add them all back together. That would give me the area of the original starting object. Now, I don't have to do it in that order or anything, and some of you might be seeing, well, there's some repetition going on here that you can use to kind of shortcut the process. All that's true as well, but the main idea and the main procedure is take an object, break it down into its faces, add those areas together, and then be done with it. So let's see how that works for a few of these shapes here. We're going to start with the rectangular prism. Just another quick definition note here. A prism is when you have two objects that are connected at their corners. So a rectangular prism is when you have one rectangle, then you have a copy of that rectangle, and then you connect their corners, and that forms a prism. A triangular prism would be when you have one triangle, a copy of that triangle, and then connect their corners. That'd be a triangular prism. Same thing for octagonal prism and pentagonal prism and all that stuff there. So right now we're going to be looking at rectangular prisms, which is basically just a bunch of rectangles put together. But let's see how their surface area goes. So I need to start cutting apart this first object here, and I'll start with the front because it seems to be the closest. So I'm going to start cutting off this front piece right here, this front slice. Well, if I cut that off and redraw it here, this is the front. If I cut that off and redraw it, that will be a 2-inch by 3-inch rectangle, because again, 3 inches are the lines that are going up and down, which is what this line right here is, and this line right there is 3 inches. Well, how do I find the area of a rectangle? It's just length times width, so 3 times 2 gives me an area of 6 for the front. Well, that's all well good. Let's try the back now. So if I go to the back, and I trace that part out, boom, 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 boom. Try the back side here. I find that is also a 3 and 2-inch rectangle. 3 on the side, 2 on the bottom, which means its area is also 6, which is pretty nice. I have a repeated shape there, makes my calculation a little bit easier. Let's try the left and right spots now. So we'll try the right side first, which is this side right here. If I look at that right side, it looks to be about an 8 by 3. So the right side is an 8 by 3, which makes its area 8 times 3, which is 24. If I go to the left side now, I also find that it is 8 by 3. It's the exact same rectangle as the right side. 8 by 3, area of 24. Now you can probably guess what's going to happen with the top and the bottom, but just to be sure and to be clear, let's look at how the top and bottom shapes go together. Because we've had 2 repetitions so far, probably likely we're going to have a third one here. Let's look at the bottom. The bottom is a 2 by 8 rectangle. So if I were to draw that up top here, so the bottom is 2 by 8, which makes its area 16. If I look at the top, it is also 2 by 8. So 2 by 8, which also makes it 16. So the front and the back are the same, the left and the right are the same, the top and the bottom are the same, and this really only happens in rectangular prisms in most cases. And because of this, we have a shortcut we could do, but we'll talk about that in another shape. Let's try to get this one done first. So if we add up all these areas together, so to get the area of the original 3D shape, we're going to add up front plus back plus left plus right plus top plus bottom. All of these come together, and we're going to make 6 plus 6 plus 24 plus 24 plus 16 plus 16, 92 square inches of space. So the surface area is 92 square inches around that object. Now, once again, as most of you are probably looking at here, this idea of repeating the shape, so front and back, left and right, top and bottom, because we keep repeating these shapes, because we keep repeating these numbers, there's a shortcut we can apply to just rectangular prisms. So this shortcut I'm about to show you here is applied to just rectangular prisms, nothing else. So if I label this next one here, if I label this 5 length, this 7 width, and this 3 height, or sorry, this 2 height, and it doesn't matter which one you call L, W, or H. So the labeling here isn't important. But what I can do here is, instead of doing each one twice, I can just say 2 times the length and the width plus the width and the height plus the height and the length. I'm just going to multiply each pair of numbers together, add them up, then double. Because essentially what I'm doing is I'm doing each rectangle once, and then adding it together, and then doubling it, because I know that each rectangle happens twice. So instead of writing it and drawing it all out, I'm just going to do it once, add it, and then double. Saves myself some time. So this would make 35. This would make 14. This would make 10. If we add those together, 35 plus 14 plus 10 would give me 59. And then we double that, 59 times 2 would give me 118 square meters. So in this case, it takes a little bit less work, a little bit less space to write the work, because we're kind of applying a shortcut here. Instead of drawing out each individual shape piece by piece by piece, we just solve it, add it, and double it. But again, that trick only works for rectangular prisms, for box shapes. If you have, let's say, a triangular prism, then you have to stick with the first method, which is cut it apart, find the area of each piece, add it back together. Speaking of which, let's take a look at how some triangular prisms behave. So here we have 2 triangular prisms. We'll start with the one on the left. We have a front triangle, back triangle, then we have a left side, a right side, and a bottom side. So we have 2 triangles, front and back, and 3 rectangles, one on the left, one on the right, one on the bottom. And we want to find the total surface area of this shape. Well, let's start with the front side. So that front triangle there. Well, that front triangle seems to have a base of 5 inches, and it seems to have a height of 6 inches. Now, if you remember, the area of a triangle is base times height divided by 2. I could label the diagonals of the triangle, but because the diagonals have no impact on the area, I'm just going to not label them to save myself some clutter. So in this case, we'd have 6 times 5 divided by 2, which is 3 divided by 2, which is 15. Now, in this case, the back side is the exact same as the front side, because the back triangle is the exact same. This front triangle and this back triangle are the exact same dimensions. So this would also be equal to 15. I won't draw and label the triangle just to save myself some time. I'm just going to solve it and move on. So the front and the back side are the same. No unique work needed there. Let's start with the right and the left here. So let's talk about this rectangle right here on the side, this right side rectangle. What are the dimensions of that? Well, it looks to be about 8 by 7. That little slanted rectangle there, 8 by 7. Well, how do I figure out the area of an 8 by 7 rectangle? Just do 8 times 7, gives you 56. Now, for us in this case, the left rectangle is also the same as the right rectangle. So this rectangle right here is also the same. It is also 8 by 7, and it also has an area of 56. So we have a lucky repetition in this case. The bottom rectangle is slightly different, though. So the bottom rectangle here, and here looks to be about 7 by 5. So that bottom rectangle, 7 by 5, which makes it an area of 35. So the bottom one is slightly different, but the rest are kind of repeated. And once again, as before, we're going to take all these areas and add them back together. So the two triangles, 15 plus 15, plus the left and the right, 56 plus 56, plus the bottom, 35, gives me a total area of 177. Okay? Once again, I'm just adding up all these areas together. And this would be in inches squared because it is still an area measurement. So in this case, we had some repetition with triangles as well. We had the left the same as the right. We have the front the same as the back. Now, the front and the back of triangular prisms, the two triangle parts of them, will usually be the same. In fact, will always be the same. So the two triangles in a triangular prism will always be equal, but the rectangles might be different from each other. So in this first case, we had two of them that were the same, but that doesn't always happen. For example, this next one here. Let's look at the two triangle pieces first. So let's look at this front triangle right here. So again, I don't need the diagonal piece. I just need the base and the height. So the height here is 3, and the base right here looks to be about equal to 4. So the area for this triangle is 3 times 4 divided by 2, which is 6. And this back triangle, again, is the exact same as the front. So it is 3 by 4, which is also 6. So again, the two triangle pieces, always going to be the same. I don't label the diagonal because I don't need it. But let's look at the rectangular pieces now. Let's look at the left, right, and bottom. So let's look at the slanted edge here first, the right side. This right rectangle here looks to be about 10 by 5. So I'll write that over here. Looks to be about 10 by 5, which is going to give me an area of 50. Let's look at the left rectangle. So this one right here looks to be about 3 by 10. So 3 by 10. So I'll draw that over here. 3 by 10, which gives me an area of 30. And then lastly, we need the bottom rectangle. And the bottom rectangle looks to be about 10 by 4. A little bit hard to see there because it is on bottom, but it is a 10 by 4 rectangle. So 10 by 4, which gives me an area of 40. And so my surface area, as it has been before, is simply taking all these areas, 6 plus 50 plus 40 plus 30, and I'm going to add them together and get my answer of plus. Let me write that in there, 132 square units. They don't give me a label here, so if you must label it, you'd say it's units squared. Because you don't have a specific label, so you just say the word units. But that is the surface area of that triangular prism. Notice how there is no shortcut to this. There's no quick formula you can do here, but there is still the piece apart, dissect, and add back together aspect of it. Now let's look at some that aren't prism related. So we've done rectangular prisms, we've done triangular prisms. Let's look at, say, a pyramid. Now, pyramids are a little bit easier because they're really composed of just two shapes. They have a base shape and triangles along the outside. So let's see how they break down. And like I said, they have quite a bit of repetition to them if you have a regular base. So in this case, we have what it's called a square pyramid. A pyramid, by the way, is defined as a shape with all its corners connecting up to a single point. So in this case, we have a square on bottom, and all the square's corners connect up to a single point. And we want to figure out what's the surface area of this pyramid. Well, we're going to start with the base shape, which is the square. Again, these little dash marks means that each side is the same. So if this side here is 4, that means every other side with a dash mark is also 4. So we have a square that's 4 by 4, which gives me an area of 16. That one didn't go so bad. Now I need to figure out the area of the triangle pieces. We need to figure out the area of these little triangles here. And lucky for us, all these triangles are the same if you look closely. If I draw one out here, the 7 feet there, that diagonal dotted line, is what's called the slant height. It's basically how far you would slide down the pyramid from the top point. And that slant height is actually just the normal height of that side triangle there. And again, because all the triangles are the same in this pyramid, that slant height is going to be the same for each triangle. So that 7 feet is the height of every single one of those triangles. And the base of the triangle, the bottom of the triangle, is those little dash marks, those 4 sides. Each base of the triangle is 4 feet. So now we have all the information we need to find the area. We have the slant height, that's 7. The base length, that's 4. Well, to get the area, that's just 7 times 4 divided by 2, which gives me a nice 14. Now, this 14 is just for one triangle, though. This is the area of one of the triangle faces. But if I look at this pyramid, I actually have 4 triangle faces. I have one here, I have one here, I have one here, and I have one in the back. So I have 4 triangles, all repeated. So I'm going to do 14 times 4, because I have 4 triangles that have an area of 14 square units each. So instead of doing each one individually, I'm just going to do a quick multiplication and get a total area of 56 for the triangles. Now that 56 is what's called the lateral surface area, because it is the surface area of just the triangular parts of the pyramid. It does not include the base shape. It is just the triangular pieces of the pyramid. So that has a lateral area, or a lateral surface area, of 56 square units. If I want the total surface area, all I do is I take 56 plus the base, which is 16, and I add them together. And that will get me my total surface area of 72 square units. So my total surface area is 72 units squared. My lateral surface area is just 56 units squared. And most of the time, people will ask for the total surface area, so that addition part there can become very important. But as I said, pyramids always do this sort of thing where they break down into one base shape and then a bunch of repeated triangles. You won't always have triangles that are repeated. For example, if you have a rectangular pyramid, some of the slant heights might be different for the 2 side triangles rather than the front and the back triangle. But for the most part, for regular pyramids, which is what this is, you just find the area of the base, find the area of one triangle, figure out how many of those you have, and then add that total triangle area to the base area and get your answer like this. Again, dissecting and adding back together. There's one more shape to go through here, which is a cylinder. And a cylinder is done the exact same way. You break it apart and you add up all the areas together. But a cylinder breaks down kind of special because it's not a rigid edge shape. It has some curves to it. And you'd find that if you have a cylinder, after you cut off the top circle and after you cut off the bottom circle, you have a tube portion on the side there. Well, if you cut that tube portion down the middle, it will actually unfold into a rectangle. So a cylinder is basically 2 circles with a rectangle wrapped around their circumference, wrapped around their edges. And we have an area, or a formula, to find this surface area, because we know that each circle has an area of pi r squared. Each circle is pi r squared units in area. And the rectangle has a height, we'll call that h, which is actually the height of the cylinder itself. So this right here is also h. So the rectangle is h units high. And the other part of the rectangle is actually just the circumference of the circle. So this part right here, the part that actually wraps around the circle, that has a length equal to the circumference of the top circle or the bottom circle. They're both the same, so it doesn't matter which one you choose. So this one's actually 2 pi r units long. So the area of this rectangle here is length times width. 2 pi r, h. 2 pi r times h. And as we know from before, the surface area is just what happens when I add all this stuff together. When I add this plus this plus this, when I add all that together, that's my surface area. Well, if I take this cylinder and add them all together, what this makes is the following formula. 2 pi r squared, so this is the 2 circles. That's the area of the 2 circles, plus 2 pi r h. That is the area of the rectangle, of the tube part. So the area of the circles plus the area of the tube gets me the total surface area of the cylinder. And that's the form we go to when we want to find the surface area of any cylinder. Big, small, fat, skinny. That formula works for any cylinder. Let's put it into practice here. So we have a cylinder, 8 feet by 12 feet. Now notice that when I write down the formula, 2 pi r squared plus 2 pi r h, it's all in terms of radius. It's all dealing with r, not diameter. So the first thing you should do when you have a cylinder, if you don't have the radius, take your diameter, cut it in half, and make sure you know that your radius is 4. Remember, the radius of a circle is half its diameter. So if my diameter is 8, I cut in half, my radius is now 4. And that's going to be my R unit. So I'm just going to go ahead and plug this number in for R. This is still my height. So it's going to go like this. 2 pi 4 squared plus 2 pi 4 times 12. It's what we call a plug and chug problem. You take your numbers, you plug them in, you get out your answer. Now I'll be using the pi key for my calculations here, so if you're using 3.14 as an estimate rather than the pi key, your answer might be slightly different, but should be roughly in the same ballpark. So this part right here, that's about 100.53. If I do this part, 2 times pi times 4 times 12, I get an area of 301.59. And so my last step is to, of course, add them together. 301.59 plus 100.53. And that'll give me a total surface area of 402.12. And this will still be feet squared. So we really don't physically cut apart a cylinder. We don't draw it out like we did with the prisms or the pyramids. We just have to know the formula because the formula will do all the cutting for us. The formula is what you get when you cut out any cylinder, and because it is the same for any cylinder, then we can just use it for any cylinder. So that is an overview of how to find the surface area of the 3 most common types of shapes: prisms, pyramids, and cylinders. Most any 3D shape can be done the exact same way as long as you can figure out what the individual faces are, how to find the area of the individual faces, and then add them back together. You can find the surface area of anything, including shapes that we did not go over in this video. But for prisms, pyramids, and cylinders, this is how we do it. Hope you enjoyed the video. Have a good day.